Welcome back to my channel. So today we are going to look at the other application of refraction in our daily lives. We are looking at a pencil being put in a glass of water. The pencil or a stick or a pen put in a glass of water appears to be bent, and the phenomena behind this, what causes this occurrence, is refraction. Reminding ourselves about what refraction is. Refraction is the bending of light rays as they move from one optical media to another with different optical densities. Okay, we know very well that as the rays of light are moving from a more dense media, take for example water or glass as compared to air, to a less dense media, here we are considering air, the rays of light tend to move away from the normal. Okay, looking at this, we are going to consider the yellow pencil, this yellow orange. Okay, we are considering the orange pencil, which is immersed in water. We have got the two optical medias, that is water and air, taking in consideration that water is more dense while air is less dense. When we put the pencil inside the water, the distance from where the pencil is to the surface of the water is what we call real depth. Real depth is the distance from the actual image to the surface of the water. Now, as our observer, who is the eye, is in the air, rays of light are going to come from the bottom, from the tip of the pencil at the bottom, and they will be incident to the surface of the water. Remember, water is a more dense media. The rays of light coming from the tip of the pencil are going to be incident to the surface of the water. We are assuming there is a normal line at the surface and where the ray is incident. So here for this case we have got two normal lines there, where the ray is incident, where these rays are incident. These rays are going to be refracted into the observer's eye. As they are refracted into the observer's eye, it is clearly being seen that they are moving away from the normal. Since we all know that light travels in a straight line, these refracted rays from the observer's eye, what the observer is viewing, he or she is viewing these rays traveling, the refracted rays traveling in a straight line. As they are traveling in a straight line, the refracted rays tend to merge at a point. A point where the refracted rays tend to merge is where our virtual image is seen. This is the point where our tip of the pencil will be viewed by the observer who is in the air. At that point, from the virtual image to the surface of the water is what we call our apparent depth. So apparent depth is the distance from the surface to the virtual image. As us who are outside, we view the pencil or the stick or the pen being bent. And in actual sense, this is being brought about refraction of light. Thank you.